In this latest version of EMO, we have completely changed the way that the SFT constraints are calculated in scenarios and in forecasts. Whereas before we had to mine historical data to try and work out the parameters in the constraints, which severely limited our ability to cope with new situations, for example, where constraints weren't in the historical record, now we have underlying conductor and cable data provided by Transpower, which we can use for pretty much any SFT situation. So this is a big step forward, and testing so far is showing that the new algorithm for SFT constraints using the new conductor and cable data is significantly better than in previous versions. So in some ways, although the SFT calculation algorithm has changed very significantly, the changes that you'll see on EMO are very minimal. In actual fact, there's virtually no change to the interfaces in EMO from previous versions. All of the changes are under the hood, so to speak. However, you will notice under circuits a couple of new columns. So each circuit now has an SFT PF, an SFT PFQ, an SFT Threshold, and an SFT Tmax. Notice that not all circuits have valid values here, and that's because not all circuits are set up to be used in SFT. We are using data provided by Transpower, so conductor data, but also circuit data. So the circuits have conductors, but the circuits also have other parameters, for example, the number of conductors, the offload time, and associated with each circuit, we have to calculate the curves that are used within EMO to actually calculate the constraints that might pop up from time to time. So this is what we're looking at here. First of all, the SFT threshold. That's a percentage value, 85% in this example, that a constraint has to achieve relative to the protected line, which is Albany-Henderson 1.1 in this particular example, before it will be included in a dispatch in an EMO scenario or forecast. Similarly, we have two factors, a PF and PFQ, appearing for that circuit. Now, these are the parameters which vary by season, the parameters which describe the curves that are used internally within EMO to calculate the SFT constraint values. So the first one, the SFT PF, if you like, is the ratio between the post-contingent current versus the pre-contingent current, which is allowed for this particular cable. And the second one, the SFT PFQ, is the change per megawatt as the pre-contingent current changes in the post-contingent current. And finally, the SFT Tmax is a temperature in degrees Celsius which the cable sits at its maximum rating, which in this particular case, in this particular season, is just over 96 megawatts. So what we're calculating here is that this particular circuit, when it's sitting at its thermal rating of around 96 megawatts, the cable temperature in this particular season, which given that it's February happens to be summer, during the day is 80 degrees C. If we look at a scenario, you'll also see that you can change some of these values. For example, you might want an SFT constraint to appear at a lower threshold, and you could do that by entering a smaller number in the SFT threshold column for this particular scenario. Why would you want to do that? Well, there's a very good reason for it. The SFT application, which is run by Transpower, a system operator, performs its constraint analysis using an AC power flow. EMO doesn't have AC power flow, it only has a DC power flow. So EMO can't model voltage effects. It could be that the power factor for a particular cable is lower than desirable, which means that the current in it could be significantly greater than the real power transfer would imply. Now in this particular case, an SFT constraint might be thrown out by the real SFT application earlier than EMO would throw it out. In other words, bring it up for inclusion in the dispatch. So if you have concerns that a circuit might be impacted by voltage effects, you can lower that SFT threshold and you'll see that constraint potentially coming up sooner. It could indicate that it's going to be a problem in the actual market.